Hello, Econ 100B students.
Today, I want to go over the new participation activity that we have for this week, which looks at solving supply and demand stuff.
So it's going to be a example that's pulled from the book. It's a couple of different questions combined together, looking at an estimated demand function that actually comes from a real economics paper, looking at the price, the demand and supply for Canadian pork. So let's get started. Okay, so normally I would do this on the whiteboard, but I kind of feel like maybe with algebraic problems, that's not the most efficient way. So what I'm going to do is try this on the DocCam, and I'm going to ask y'all for your feedback as to how effective it is. So we're going to start with the part one of this problem, which looks at the estimated demand function. And like I said, this is all from the Perloff text, so you can go in there and find some more details on these problems if you want. Let me get that zoomed in there. So we start with this estimated demand function for Canadian pork that is Q equals 171 minus 20 times the price of pork plus 20 times the price of beef plus 3 times the price of chicken plus 2y. And so one thing we have here is we have our two non-price determinants, right? We have our three non-price determinants. We have the price of substitute goods, beef and pork, or beef and chicken, we're considering substitutes for pork. And then we have over here income. And so these are our non-price determinants of demand. And then, of course, we have price, and it's inversely related to quantity demanded. So as price goes up, you demand less. Price goes down, you demand more. So given that the quantity is measured in millions of kilograms of pork per year, and the price is P per kilogram, price per kilogram in Canadian dollars, we want to find the demand function where we hold non-price determinants constant at their typical values, which are PB equals 4 Canadian dollars, PC equals 3 1/3 Canadian dollars, and Y equals $12.5 thousand dollars, right? So we start with just inserting those numbers into our equation. We get Q is equal to 171 minus 20P, and then we've got plus 20 times the price of beef, which is 4, plus 3 times the price of chicken, which is 3 1/3, and 2 times income, which is 12.5. So we can go through and calculate that, and we get 171 minus 20P is equal to, or plus 20 times 4 is 80. 3 times 3 1/3 is 10. You can also do 3 times 3.333 and get 9.99 and round up. And then 2 times 12.5 is 25. So that gives us, when we go through and add in all of our new constants, the new estimated demand function that our quantity demanded is equal to 286 minus 20p. So far, so good, right? I'll do a little box around that. So that is our estimated demand function. Now, using this estimated demand function, part 2 says, show how the quantity demanded at a given price changes as per capita increases. So we want to find the change in quantity demanded given the change in income is $100. And remember, if this is in thousands of dollars, $100 is going to be a 0.1 increase. So the change in Y is 0.1. Okay? Okay. So to find the change in Y, we go through the same sort of steps we've done before, which is we say, okay, first we find the effect of the change in Y on change in Q. We define change in Q, which is equal to Q2 minus Q1. And then we remember that our formula for the equation for Q comes from here. And if we're going to be changing Y, then we can hold everything constant except for Y. So we can sub in our formulas for our quantity demanded at different incomes, right? Because we're changing. We're going to have change in y, remember, is equal to y2 minus y1. In this case, y2 is 12.5, y1 is, or sorry, y2 is 12.6, y1 is 12.5. So we can go ahead and sub in those values into this equation. So now we have that the change in Q is equal to this equation here, where we're not going to use that y, we're just going to call it y1 and y2. So we say change in Q is equal to 171 minus 20p plus 80 plus 10 plus 2 times y2. Do you see what we did there? So we take that estimated demand function from above, we hold the other non-price determinants constant, and the only thing that we're going to change is y. And now we can subtract Q1 from it, and Q1 is going to be the exact same function, only instead of with y2, we'll be using y1. So now I have the exact same equations, the estimated demand function with y2 and the estimated demand function with y1, which means I can go through and cancel out, right? 171 minus 171 is 0. Negative 20p minus negative 20p is 0. 80 minus 80 is 0. 10 minus 10 is 0. All that we're left with is change in Q is equal to 2y2 minus minus 2y2. Or sorry, 2y1. That's not confusing, right? Okay. That means that we can factor out the 2's and say that change in Q is actually just equal to 2 times y2 minus y1. Well, we've seen that somewhere else. That's up here. That's change in y. So really what we have here is that the change in quantity is equal to 2 times the change in y. Does that kind of make sense? Do you see how it's that same exact process we've done before with the solved problems in the slides and in the book, where we take the change in Q. We want to find the change in Q. We sub in for quantity 2 and quantity 1 the formula with just the variable we're interested in this case y, left out, and then solve for the effect of a change in y on a change in Q, and we end up with the coefficient for y2 as the change in y on the change in Q. What this means for us is if we have a change in y of 0.01, we're going to expect to see a change in Q that's twice that, or in this case, 0.02. And you can see that if you were to plug it in and say, okay, well, what's the difference between this estimated demand function and an estimated demand function with the new income? Well, it would be, right, Q equals 171 minus 20p plus 80 plus 10 plus 2 times 12.6, which you will find if you go through and do the math is equal to 286.2 minus 20p. And so again, here's the difference, right? Here's the difference between this change in Q and this change in Y. It's an additional 0.2. It's one change in Y is going to be doubled in Q. Hopefully that makes sense. If it doesn't, let me know and we can talk about it some more. So now that we have the demand function handled, we can move on to the supply side. And on the supply side, we have an estimated supply function that comes from the same paper on Canadian pork products. And so we can go ahead and consider the estimated demand function, or the, estimated supply function, Q equals 178 plus 40p minus 60p PH, which is the price of hogs, which we can consider an input in making pork products, right? You need to have pigs to make pork. And so what we can do here is hold, again, the price of hogs constant. If PH equals $1.50, what is the estimated supply function? Well, just plug it in, right? Q equals 178 plus 40p minus 60 times 150. And again, remember here, you notice that it is an upward sloping supply curve because there's a positive sign on the price component, right? So 60 times $1.50 is going to be 90. And we still have the same other components, 178 plus 40p minus 90, which gives us our new estimated supply function, holding that constant, holding that price of hogs, that input price constant. And that's what we want to remember here, is that this PH, this price of hogs, that's an input price for our firm, right, for our production of pork. So we now have Q equals 178 minus 90, or 88 plus 40p. And that is our estimated excuse me, our estimated supply function. The next thing we want to do in this question is look at the effect of a change in the price of hogs. So if the price of hogs doubles, what's going to happen to quantity demanded? One thing we know is if you increase an input price, that's going to have a change in supply. That's going to shift the supply curve, right? We know that increasing input prices is going to make it more expensive to produce that good. And so we're going to expect to see the price of pork, the supply of pork decrease. So what would that look like? We want to go ahead and do the same thing we've done before. Find the change in quantity supplied, given that the change in the price of hogs is now doubling. It's going from $1.50 to $3, so it's going to be an additional $1.50. And so, I mean, you can go through and, oops, you can't really see that, can you? Go through and try to plug that in and see what the effect is. But the methodology that they use in the book over and over again, I think is pretty useful, which is just going in and subbing the formulas in. So let's try that. So we have, remember, change in Q is equal to Q2 minus Q1. In our equation, we have change in Q is equal to 178 plus 40p minus 60 times PH2 minus 178 plus 40p minus 60. And now we want to use the initial price of hogs, right? So here's that first price, or that second price of $3, and here's the initial price of $1.50. So we go through and this clears 178 minus 178, 40 minus 40. And so we're left with the change in Q is equal to the coefficient for this change in hog price. So it's going to be equal to negative 60 times the change in the price of hogs. Does that kind of make sense? Hopefully it makes sense. Hopefully you've seen it enough times that it is comfortable and functional and works for you. If you went through and calculated mathematically, you'd find the same thing, because what we end up with is if the change in the price of hogs is $1.50, the change in the quantity is 90, and 60, increasing the price of hogs is going to decrease the quantity supplied by 90 million pounds of pork, or million kilograms of pork rather, and that's 160 times that 1.5 change. Does that make sense? So you really can go about this a couple of different ways, but what we end up seeing over and over again is the effect of a change in one element is a function of and is directly related to the coefficient for that element. Right, that's the pattern we can't see. That's the pattern we keep seeing. All right, so this page is done. I'm going to grab a new sheet of paper, and we can wrap this assignment up with the last component using the estimated supply and demand functions for pork and for the estimated supply and demand functions for Canadian pork. Find the equilibrium price and quantity, holding the other determinants constant at their initial values indicated above. So before we made any changes. And so what we're going to do is take those initial functions. So we have the quantity demanded for Canadian pork is $171 minus $20 times the price of pork plus $20 times the price of beef plus $3 times the price of chicken plus 2y, or our simplified quantity demand function is just that function that we came up with in the last section, where we just ended up with 286 minus 20p. Same thing for quantity supplied. We have the big long function where we have everything included, 178 plus 40p minus 60 times pH, or quantity supplied is equal to 88 minus 40p. If we want to find the equilibrium price, it's going to occur where quantity demanded is equal to quantity supplied. If we wanted to find the equilibrium quantity, we would have to find the inverse functions and then set them equal. And I'll show how to do that in just a second. But for now, let's walk through this real quick. So we want to set demand equal to supply. So 286 minus 20p equals 88 minus 40p. It's not 40p, not minus 40p, plus 40p, right? The demand function has an intercept and a negative slope on price. The supply function has an intercept and a positive slope on price. So now we can go back in. Sorry, I made a little mistake there and went a little too far down with that poor math. So now we can add 20p to this side. So we have 286 equals 88 plus 20p plus 40p is going to be 60p. Subtract 88 from both sides, which is going to give us 286 minus 88 is 198 equals 60p. And then we can go ahead and divide both sides by 60. So 198 divided by 60 is 3.3. So our equilibrium price occurs at $3.03. So I can go back in and plug that in here to the supply function, which would just be 88 minus, or sorry, if I make that mistake one more time, they're going to kick me out of economics. 88 plus 40 times 3.3, which would give us an equilibrium quantity of 220 kilograms of pork. I can also plug it in up here and say, okay, 286 minus 20 times 3.3, and I should get the same answer, which is 220 kilograms of pork. The other thing I wanted to do is go over the last little bit of the chapter that we didn't spend a lot of time on, which was putting this all into a graphic representation. So if we have our demand function, which is quantity demanded, is equal to 286 minus 20p, quantity supplied is equal to 88 plus 40p,
And then we found that P star is equal to 3.3. The quantity, equilibrium quantity, is that 220. We can go ahead and graph that and also look at what the two non-price determinant effects would have been in our market for Canadian pork.
If you don't like pork products, you really don't like them now, huh?
All right, so I'm just going to give us kind of a stylized demand and supply curve. And then we have our equilibrium quantity and our equilibrium price. And if we wanted to be really precise, we can go through, and I actually did it for fun.
And we can find the real location of these curves by plugging in a couple of different prices. And so we can plug in the quantity demanded at a price of 0. And then we can set, we can also set that, set that quantity to 0 and see at what price there'd be no demand, and that helps us derive that full demand curve, right? Having multiple points is how we derive that demand curve. And so what we find is the demand curve actually crosses the quantity axis, the x-axis over here at like 286. Because that's where, if you set price to 0, you get an intercept of 286. If we set price to 0, the quantity supplied is 88. It's a little unrealistic, but that gives us our general model, right? We can see that here. We can also go through the examples we did in class. So we could talk about in the assignment, we had the increase in income, right? The change in Y. That's going to shift demand out. We saw that had an increase in income, increased demand. We can also talk about the effect of an increase in the price of hogs. That was an input price that made it more expensive to produce pork, right? That's a change in the cost of production. And what we saw was that increase in price led to a decrease in quantity supplied, shifting the supply curve in, meaning higher prices and fewer quantity supplied at every level. So those are some good things to remember. We want to remember that when those things happen, so for example, if we do have the price of hogs go up, that's going to be an inward shift of the supply curve or a leftward shift of the supply curve. So we're going to go from our initial equilibrium here up to this new equilibrium on this higher supply curve. And that's going to mean that for a period of time, we might be experiencing disequilibrium, right? We might have a period where, let me take the demand curve out so we can see it a little more clearly. We'll have a period where we're having maybe a shortage of pork because the prices have gotten higher, and the market responds to that by decreasing the quantity and moving us along that demand curve. And so we want to remember those other concepts we talked about, the idea of excess supply or a surplus, excess demand or a shortage, and the effects of government intervention pushing us to a disequilibrium. And we'll talk about those more in specific, but you want to remember if we're at any point that is not equilibrium, we'll have an incentive to change our behavior. So if, say, there was some government rule that put a minimum price of pork at $4, that's going to create a disequilibrium, right? We're going to see that quantity supplied is greater than quantity demanded, and that's going to be excess supply or a surplus. We could see the same effect if for some reason the price was too low for pork. If the price was $3 instead of $3.30, we'd see that supply would be lower than demand. We would have we'd be experiencing excess demand, also known as a shortage or sorry, excess demand, also known as a shortage or a situation where we might have rationing, and that's going to give us an incentive to move back to that equilibrium. Okay, so that's it. Hopefully a lot of this was review. I know we're getting into doing a little bit more math than you might have done, at least over break. But let me know what questions you have. Let me know how you like using the DocCam relative to doing math on the dry erase board. And I'll see you all next time. Thanks.